of class 10 chemistry topic, chemical reactions and equations. So in the first session, we learned just the introduction of the chapter. In the second session, we learned how to balance a chemical equation. In the third session, we are going to learn the different types of chemical reactions. So let's move on to that. Here, types of chemical reactions. Basically, there are 5 types of chemical reactions. First one is combination reaction. In this session, there is an activity mentioned there. First, we will discuss that. In the activity, take a beaker and add a small amount of calcium oxide or quicklime. Calcium oxide is also known as quicklime. And add slowly water into it. After some time, we notice that the beaker turns very hot. Why it is so? So, there happens the combination reaction. Let me write the equation. Calcium oxide, or you can see quicklime, reacts with water and form calcium hydroxide. Calcium hydroxide is also known as slaked lime. Here, in this reaction, 2 substances combine to form a single product. Hence, the reaction is known as combination reaction. When 2 or more substances combine to form a single product, the reaction is known as combination reaction. So this is one example of combination reaction. We will learn some more. But before that, let's discuss some more information about slaked lime. Do you know what is this slaked lime used for? Actually, slaked lime is used in the whitewashing of walls. Here, we apply the slaked lime into the walls and slowly slaked lime or calcium hydroxide reacts with air and form a white substance known as calcium carbonate. Let me write that equation. Calcium hydroxide react with carbon dioxide present in air. That's what I said. Calcium hydroxide reacts with air or the carbon dioxide present in air and form calcium carbonate plus water. And this calcium carbonate is white in color, which gives the white shiny appearance to the walls. Actually, it's a slow process and it occurs within 2 or 3 days. Hence, this is all about the first example, that is reaction of calcium oxide plus water gives calcium hydroxide. And remember that this second equation is not a combination reaction. It's an example for double displacement reaction. I just wrote this equation to give an idea of the reaction that is taking place in the process of whitewashing of walls. Hence, this is all about the first example. Now, let's discuss some more examples under combination reactions. So, now let's discuss some other examples of combination reaction. First one is burning of coal. As we all know, coal is represented by carbon or C. Burning, combustion process, requirement of oxygen is necessary, gives a single product, carbon dioxide. C plus O2 gives CO2. This is the first example. Second example is formation of water. Water is formed by the reaction of hydrogen and oxygen. H2 plus O2 gives H2O. This equation is not balanced and you know how to balance a chemical equation. So, 2. Hence, now this equation is balanced. So, these are the 2 examples, other 2 examples of combination reaction. Now, we have a small topic which comes under, which is not a part of combination reaction, but comes under this. So, let's discuss that. Do you remember the last activity the reaction between calcium oxide and water, I told you that the beaker turns hot after the reaction. Do you know why it is so? Actually, it is an example for exothermic reaction because when calcium oxide reacts with water, we get calcium hydroxide and also some amount of heat. And this is the reason why the beaker turns hot and then it becomes an example of exothermic reaction. It's a reaction where heat is released after the reaction. Another reaction is there named endothermic reaction where heat is utilized for the reaction. Actually, we don't have that part to learn here. Anyway, I just mentioned that. Now, let's discuss some of the examples of exothermic reactions. The first example is burning of natural gas. We take methane as an example for natural gas. As the process is burning O2, we get CO2 plus H2O. Now we have to balance this O2 and H2O. Yes, the equation is balanced. So here heat is also released and hence the reaction becomes an exothermic reaction. So the second reaction is respiration. C6, H12, O6. You know, this is glucose. We get carbon dioxide plus water plus energy or heat. And now we have to balance this. This equation is balanced and it's an example for exothermic reaction. So this is the third example, that is decomposition of vegetable matter into compost. This is also an exothermic reaction. So these are the three examples of exothermic reaction and we discussed about combination reaction. Now the second type of chemical reaction is decomposition reaction. So we'll discuss about that. This is the second type of chemical reaction, that is decomposition reaction. Even here we have an activity to discuss. That is, in a boiling tube, take some ferrous sulfate crystals. Ferrous sulfate is FeSO4. Ferrous sulfate crystals and note the color of the crystals. After that, place this boiling tube over the flame of a spirit lamp or a burner. During the reaction, you notice some of the fumes arising from the boiling tube. So try to wave the fumes gently towards your nose in order to smell the gas. Don't try to point the boiling tube towards your neighbors or to yourself. It's very dangerous. So just smell the gas coming out of the boiling tube. This is a decomposition reaction. After the reaction, check the color of the ferrous sulfate crystals you have taken in the boiling tube and also notice the characteristic odor that you have smelled during the reaction. All these are the result of the decomposition reaction. Now we will discuss the reaction. FeSO4 gives Fe2O3 plus SO2 plus SO3. They are gases. This is solid. This is also solid. Fe and Fe2F. So this is the reaction taking place. And now we will discuss about the changes happened in the reaction. During the reaction, you notice, first of all, the ferrous sulfate crystals are green in color. But after the reaction, when you notice the color of the ferrous sulfate crystals, you got it as reddish brown or black in color. Reddish brown or black in color. And also, you notice a characteristic odor during the reaction. This is the process happened in the reaction. Now we will discuss about the change in color and presence of the odor. Actually, ferrous sulfate crystal is present in a hydrated form that is FeSO4.7H2O. And during the heating or boiling, it turned as FeSO4. This 7H2O molecule gives green color to the compound, while on heating the water evaporates. Hence, we have only FeSO4, which is reddish brown in color. So this is the reason for change in color, and only after this FeSO4 will decompose into Fe2O3 and SO2 and SO3. Now, what is the reason for the characteristic order? Actually, the sulfur compounds, that is SO2, SO3, produced during the reaction gives the characteristic order for the reaction. Hence, these are the changes happened in the reaction, and it is a decomposition reaction because a single product, that is FeSO4, converted into three products, that is Fe2O3, SO2 and SO3. So, when a single substance decomposes into two or more products, then the reaction is known as a decomposition reaction. So, this is the first example of decomposition reaction. Now, we will discuss some more examples. Another example of decomposition reaction is decomposition of calcium carbonate. Calcium carbonate is also known as limestone. It is quicklime. On heating. So here one substance decomposes into two or more substances, hence it's a decomposition reaction. Here we notice it is carried out in presence of heat. The earlier activity what we studied about ferrous sulfate is also carried out on heating. Hence the reactions or the decomposition reaction taking place on heating are specially known as thermal decomposition. The decomposition reaction carried out on heating are called thermal decomposition. Now we will discuss another example for decomposition reaction. This is the third example. It's an activity. Same as the earlier activity. Take a boiling tube and add some amount of lead nitrate into it and place this boiling tube over the flame of a burner or a spirit lamp. During the reaction, you will notice the emission of brown fumes. Now we'll discuss the reaction. Lead nitrate, PbNO3 twice. I have written the reaction. PbNO3 twice on heating gives PbO plus NO2 plus O2, and the brown fumes during the reaction is due to NO2. The emission of NO2 gives the brown fumes. Hence, this is the third activity. Now we have one more activity to discuss in the decomposition reaction. Now we are going to discuss the third example. It's an activity. Here, take a china dish and add some amount of silver chloride. Then place this china dish in sunlight. Before the reaction, we notice the color of silver chloride is white. Before the reaction, silver chloride is white in color, and when we place it in sunlight, we get Ag plus Cl2, where Ag is grey in color. So there is a change in color from white to grey, and here a single product is decomposed into two products in presence of sunlight. So this is a decomposition reaction. Similar to AgCl, decomposition of AgBr is also a decomposition reaction. Presence of sunlight. So all this reaction of AgCl and AgBr are used in black and white photography. So activities detailed in the portion of decomposition reaction. One more activity is mentioned there, that is the electrolysis of water. A complete diagram and procedure of electrolysis is mentioned. You may refer it and find out the actual procedure. I'm just giving a brief description about that here. So here we take a mug and make 2 holes at the bottom and fix it with rubber strippers and place 2 electrodes, 2 carbon electrodes, and fill the mug with water in such a way that the carbon electrodes are completely immersed. Now add a few drops of acid in it, into the water, and then cover the electrodes with test tube which also contains water. Now connect the electrodes with a cell of say 6 volt. Now let current pass through them, and after some time we notice that the water in the test tube are replaced by bubbles. And after a particular time, all the space in the test tube is covered with bubbles. So we know the electrolysis of water decomposes to form hydrogen and oxygen. So either of these test tubes contain both gases, hydrogen and oxygen. So we have to find which one is oxygen and which one is hydrogen. For that, remove this test tube from the setup and place this test tube towards a candle, a burning candle. Which test tube produces a pop sound near the candle will be hydrogen gas, and the other one will be oxygen gas. So this is the simple activity to explain electrolysis of water. So by this decomposition reaction is over. Now we will move on to the other type of chemical reaction.